Hello, good morning everyone. Now today we will revise. Okay, we will revise once more about the properties of integers, of addition and subtraction. Okay, first of all we had already learned the natural number. What is natural number? So natural number is only that we can count. Okay, what is this? Suppose there are three apples. Okay, three apples. There are three apples. Okay, this is three apples. Okay, let us count. This is 1, 2, 3. How many apples are there? 3 apples are there. Okay. Now count 1, 2, 3. How many is 3 counted? And how many apples are there? 3. So here we don't need 0. Here we don't need the 0 now because 3 apples are there. When we count 3, 1, 2, 3. Counting also 3. And how many apples are there? Apples are also 3. So here we don't need the 0. Okay, here we don't need the 0. That's why this is natural number. Okay, I told many times that where there we don't need any 0, that number is called counting number, and counting number is natural number. Okay, so what is natural number? The natural number is the counting number because there are 3 apples are there on the table. Suppose this is the apple. Okay, how many apples are there? 3 apples are there, and let us count 1, 2, 3. When we count, we get 3. Then 1, 2, 3. We get 3. How many apples are there? 1, 2, 3. Yeah, we don't need what? 0. We don't need the 0 now because 3 apples are there. When we count, also 3. So this is counting number, and obviously this is natural numbers. Okay, what is natural number? Natural number is nothing but it's a counting number. Okay. Then comes what? Then comes whole number. What is whole number? Suppose if I measure, suppose this is the wall of my fencing. Okay, this is the wall of the fence. Suppose here I have to measure the length of the fencing. Then here, suppose how many meters? Suppose I said 1 meters, 2 meters, 3 meters. Suppose I gave 1, 2, 3. Okay. Now you see how many meters are there? This one is 1 meters, and here 2 meters. When we write 1, 2, 3, but only how much we get? Only we get 2 meters. 1 and 2. So here we need the 0. Without 0, we can't get the 3 meters. Here I write 1, 2, 3. But actually, how much I got? 1 meter, 2 meter I got. So here we need the 0. Okay, 0, 1, 2. Now how many numbers are there? 2 numbers. And how many meters? 1 meters, 2. Here we start. Here we have to start with 0. Without 0, we can't get the meters with ones. So how many meters are there? 2 meters. You see 1 meter and 2 meters. How many meters? 2 meters. And how many numbers? 2 numbers. So we have here we need the 0. That's why this is whole number. We start with 0 because here we need, without this 0 we can't get the actual the meters that we want. So we have to start with the 0. When we start with the 0, that number is called whole number. Okay. Now how many numbers are there? 2 numbers are there. And how many meters are there also? The length of the this fencing, 2 meters. Then 2 and also 2 meters. So we got the perfect. That's why when we start with the 0, that is called whole number. Okay. Then integer. Okay. What's come then? Integer. Suppose if I don't have any money in my pocket, then it's become 0. But I have some loan. I have to give some money to others. Then I have some loan. That loan is lesser than 0. That is lesser than 0. Now, suppose I have 100 rupees. Suppose 10,000 loan. I have 10,000 loan. That means less than 0. That means less than 0. Now, when I get the 10,000, then I have to pay back. Then I have to pay back means if I get 10,000, then I have to pay back. Then I become what? 0 again. That's why if I have some loan debts, that means I have the less than the 0. The money that I have is less than the 0. Then less than the 0. I suppose my friend, one of my friend has suppose 1 lakhs. Okay, that is more than 0. He has more than 0. That's why when these 3 comes together, this is negative integer, this is positive whole numbers, and this is 0. When these 3 comes together, that is called integer. Integer means lower than the 0 and greater than the 0. then you can say the integer. Okay. Now after integer, then comes properties. Okay, we have learned all this thing. Now properties. In properties, first of all, closure properties. Closure properties. Suppose in addition, closure. Okay. Suppose this is the closure of integer 2, 5, 3, minus 7, 8. These all are closure. Now this is close. Okay. This is close. Closure of integer. Suppose this is closure of rational number. Okay. This is rational number 3 by 7. This all are rational number. This is not integer. This is rational number. This is the closure of rational number. This is the closure of integer. Suppose when we add, suppose there are two integers, two integers, minus 5 and 2. Suppose this is a 2 integer. Okay, minus 5 and 2. Add this. Okay, minus 5 plus 2. How much we will get? We will get minus 5 plus 2. How much? Obviously, how much we will get? We will get minus 3, because here negative integer dominates the positive integer. That's why the result will be in negative integer. Minus 5 plus 2, how much? Minus 3. So this minus 3 is what? This is also integer. Then this 3 will goes to where? This will goes to integer closure. Okay, closure of integer. Here go. It will not go to this. It will not go here. Go there. Okay. It will go to the integer closure, minus 3. So when we add two integer, the result, the sum will be also a integer. Okay. When we add two integer, okay, whether it is negative integer or positive integer, but when we add two integer, the sum means after adding. Sum means after adding. Sum means what? After adding. What will we get? We will get the integer, not the rational number. So it will go to the integer closure, not to the rational closure. So it is closure. That's why integers are close under addition. So integers are close under addition. When we add two integers, whether it is positive or negative, but when we add two integers together, the sum, the answer, the result will be also an integer. So addition, so integers are close under addition. Okay. Subtraction also same. When we suppose these two are integers. This is negative integer. Minus 5 is negative integer. This plus 2 is positive integer. When we subtract these two integers, okay, subtract this minus 7, minus 2, how much we will get? Difference will be minus 7. Negative, total negative. Negative, total negative. Okay. Minus 5, minus 2. How much we will get? We will get minus 7. This also a what? Integer, not a rational number. So it will go to integer closure, not to the rational closure. Okay. So this is also an integer. When we subtract two integers, whether it is negative or positive, when we subtract two integers, the difference will be also a integer, not the rational number. So integers are close under subtraction. When we subtract two integers, the difference will be also an integer. That's why integers are close under subtraction. Got it? Okay, now next. Only today's revision class because we missed lots of days due to some problems. So I thought today is better to revise. Okay. Now next, commutative properties. This commutative, I said now commute. Commute means what? Commute means travel. To go from one place to another, that is commute. Okay, commute. So commutative. Commutative means suppose there are three integers. Okay, minus 7 to minus 5. These are, suppose these are three integers are there. Okay, minus, this is negative integer, this is positive integer, this is also negative integer. How many integers are there? Three integers are there. Okay, now commutative. Okay, suppose 8 minus 7 plus 8, these three integers. Okay, 2 plus minus 5. Okay, when we add, because addings are there. Okay, in addition, we can change the order of the number. Order means change the number. So this is first order. Okay, this is the second. Okay, this is the third. First, second, third. This is the order. Order means first, second, orderly. Okay, first, second, third. That's first, second, third. This is order. We can change the order because additions are there. Na? In addition, we can change the order of the number. Second place we can place in first place. Okay, suppose 2 is in the 7th negative integer, then minus 7, okay, plus minus 5. Now here I have changed the order of the first and the second, okay. I put the second in the first and first in the second. I change here, okay. Here these two integers commute, okay. It travel to the first and this travel to the second. Here we change. Then this commute, okay, commute. But result is same. See, minus 7 plus minus 5 minus 12. Minus 12 plus 2 how much? Minus 10. Okay. Here also we will get the same result. Minus 5 minus 10 how much? Negative, negative. Total negative. Minus 7 minus 5 how much? Minus 12. Minus 12 plus 2 how much? Minus 10. So no difference in the result. Okay. So in integer, in the addition of the integer, we can change the order of the number. Okay. That is commutative properties. In commutative properties, we can apply the commutative properties addition. Suppose in subtraction, okay. Now, suppose it is subtraction. Take it. So in addition, we can change. Okay, we can apply the commutative properties. Commutative properties, we can change the order of the number. But in case the subtraction, suppose subtraction minus 7, minus 2, minus 5. Okay. Now this is the subtraction. Okay, subtraction. Okay, here we change the order of the now change minus 2, okay, not minus, this is plus and it's okay, nothing is there and plus is there, okay, inside we can put over like this, okay, for this is minus 7, okay, now subtraction, this is plus now, but we don't write, this is minus 5, okay, this is plus, okay, nothing is there and plus is there, okay, this is plus 2. Suppose if I change the order of these two integers, suppose change it, okay, now plus 2, okay, this will go and minus of minus 7, minus of minus 5 is equal, okay, now, see, this is nothing then plus, okay, minus 7 plus minus, okay, minus plus, how much you get, this is minus 7, minus plus minus 2, okay, minus plus 5, how much you will get, minus 2 minus 7 minus 2 minus 9, minus 9 plus 4 minus 4, okay, minus 2 minus 7 minus 9, okay, then plus 5, how much you will get? 4. Which sign dominate? The negative integer dominate, okay, then the negative integer will be in the difference in the result. Now here 2 minus plus 7, okay, minus plus 5 is equal to the whole process same, different, change, totally change. 2 plus 7, 9 plus 5, 14. Here totally change now. I have changed the order of the number here. I have changed the order. Okay. This two. This is first, second order. Now I have changed this order of these two number. Okay. Then the result is totally different. Okay. See. One is minus 4 and another one is 14. Totally change. So we can't apply the subtraction. Okay. Commutative property cannot be applied on the subtraction of the integer. Okay. In addition, we can apply the commutative properties. But in subtraction is there, then don't change the order of the number. If you change the order of the number in the subtraction, there will be wrong. You will don't get any mark. Okay. If there is addition, then we can change the order of the number. But if there is a subtraction, don't change the order of the number. Okay. If we change the order of the number in subtraction, then whole process will be wrong. Okay. So in addition, if this is addition, then we can change the order of the number. If it is subtraction, we can't change. So we can apply commutative properties only in the addition of the integers, not in the subtraction. That is very important. I have told many times. This is okay. Now after commutative properties comes associative properties. Okay, associative. Okay, associative means what? Associative means group. Okay, associate. When two or more people come together, that is associate and do some work for the welfare of the people. That is association. Okay, women association, women welfare association, football association, lots of association. In mathematics also association. Suppose 4 integers are there. Okay, 2 minus 6, 4 minus 3. How many integers are there? 4 integers are there. See, 2 minus 6, 4 and minus 3. How many integers are there? 4 integers are there. Okay, now add 2. All of them add. Okay, add 2 plus minus 6 plus 4 plus minus 3. Okay, always negative integers should be under bracket. Okay, now suppose if I associated, okay, these two first, these two associate. Okay, now how much we will get? 6 plus 2 plus minus 6, you know, how much you will get? Minus 6. And plus 4, how much? 2 plus 4, 6. Or minus 6, 0. Okay, 0 plus minus 3 equal to how much you will get? Okay, let it do properly. Okay, 2 plus minus, okay, and plus 4 plus minus 6 plus 4, okay, plus minus 3. First I have grouped these three integers. Okay, group, that means associated. These three becomes associated, okay, each other. So first I have grouped these three integers. Okay, then I will solve this first. Okay, 2 plus 4 positive together how much? 6 minus 6 how much? 0 plus minus 3 how much I get? Minus 3. Okay, now I have changed in, suppose if I change these two first again, 2 plus minus 6 plus 4 plus minus 3. Okay, first I group these three. Okay, I like to group these three integers. Okay, first, then how much, what will the result? 2 plus minus 6 plus minus 6. Okay, this is plus 4 plus minus 3. Okay, then 2 plus bracket 6 minus 3 negative, total negative, minus 9 plus 4, then 2 plus minus 4 minus 9 minus 4 minus 5. Okay, then how much you will get? Minus 3. Okay, here will you get 2 plus minus 5, how much you will get? Minus 3. So I change the grouping. First I group these three, it is first, second, third. I group the three, first, second, third. Okay, so first three, 1, 2 and 3. The result is minus 3. Then after I group the another. Okay, second, third, fourth. Group this one and I done solve this first one. Then how much I get? The result is minus 3. So same, I got the same. That means we can apply the associative property in addition of the integer. In addition of integer, we can apply the associative properties because I have changed. Okay, this associate, this grouping, but result is same. So if that's in addition, we can apply the associative properties. See, first I group first, second, third, result is minus 3. Then I group second, third, fourth, result is minus 3. That means we can make the group if there is addition of integer. Okay, suppose if it's negative, suppose it is subtraction, let us do the subtraction. 2 minus 6, okay, minus 4 minus 3. This is subtraction. Okay, nothing is there, the plus is there. Okay, now how many integers? 1, 2, 3, 4 integers there. In addition, I already done. Now this is subtraction. Okay, now first I group these three. Okay, I group these three. It's the first, second and third. Now let us solve. 2 plus minus plus 6 minus 4. Okay, minus plus 3 minus plus 3. Okay, then how much we get? Positive, total positive 8 minus 4. Okay, now plus 3, 8 minus 4. How much? 5. Positive integer greater. That's why the sign will be in positive integer. Plus 3. How much? 5 plus 3, 8. How much I get? 8. Now I change. I have now changed the group. 2 minus 6 minus plus 4 minus 3. But if there's plus, no need to give the bracket. But for your understanding, I gave the under bracket. Put under bracket the positive integer. Okay. Now solve. Okay. Now this time I group this second, third, fourth. Okay. Now in this I group second, third, fourth. Okay. Now solve this. 2 minus, okay, minus 6 minus plus minus 4 minus plus 3. Okay. 2 again minus 6 minus 10 plus 3 minus 10 plus 3 minus 7. Okay. Now 2 minus plus 7. How much? 9. Now see, I change the group. First I group first, second, third. And next I group second, third, fourth. Here I got how much? 8. Now here I got how much? 9. That means the result is not same. That means we can't apply the associative property in the subtraction of integer. Okay, same. In commutative properties we can't apply this property in the subtraction. In associative property also we can't apply the associative property in subtraction of integer. So this is very important. So okay then, today's very important class. And that's all for today, and have a nice day. Thank you guys.